All right, good morning, everybody at home. Can I get a thumbs up that you hear me and see the board okay? Awesome. All right, guys, there's a lot of cameras on. Cameras should be, there's a lot of cameras off. Cameras should be on. All right, we're going to pick up where we left off yesterday. Yesterday, I kind of set you guys up for what you're going to need to find to graph these higher degree polynomial functions. Today, I just want to get right into the graphing, all right? So I did give you a list of steps that you should follow. If you're ever on your own and you're lost, you're like, oh, what was I supposed to do next? Here you go. So just remember, the first thing you're going to want to identify, and really it's some of the only official things that you have to put on the graph, are the x-intercepts. After the x-intercept and the y-intercept, everything else on the graph is literally just a sketch. And based off of the rules that we're going to follow, then you should kind of feel the graph almost graphing itself. Okay, so you have this list of steps to refer back to. And I just want to keep reminding you that this is just a sketch, so my graph could look a little different than yours, but there are certain details that have to be the same, okay? If you wanted to create a more exact graph, then you just have to create more exact points. Plug more x values in, get more y values out, and you can literally create all the exact points on the graph that you want. All right, here we go. Let's look at example 1A. There we go. Okay, so the first thing you want to do is they've asked you to sketch the graph of all of these polynomial functions. Well, guys, the good news is, because this is the first time we're doing it, I have given you all of the polynomials in factored form. So you're not going to have to factor it on your own to find the x-intercepts. We're going to have them all factored for you. In the next few days, we'll start seeing the ones we have to factor, though. All right, so guys, the first things first, let's find the x-intercepts. So let's set this equation equal to 0, and let's solve. Now we set each factor equal to 0. So I'm going to try and shortcut this. Guys, if I set this factor equal to 0 and solve, who would x be? X would be equal to -3, right? If I set this factor equal to 0, x would equal 2. If I set this factor equal to 0, x would equal 5, right? Those are the x-intercepts. Those are the numbers that your graph is going to cross over the x-axis at. So guys, let's put them on there. All right, we got 2. It's crossing over when x is 2. It's going to cross when x is 5. It's going to cross when x is -3. Now, just to warn you, because your x-intercepts, the graph can get a little crazy, I think you should try to space out your hash marks a little bit. I may even put them a little too close. All right, guys. The next thing you want to do is, after you find your x-intercepts, let's get the y-intercept, because sometimes they'll ask you to do that. So if you want to get the y-intercept, x has to be 0. So you have to plug 0 in for x. Guys, plugging 0 in for x is literally us finding f of 0. Just in case you see delta math or any of them talk about f of 0. So if we plug 0, and guys, watch this. What's 0 plus 3? 3. What's 0 minus 2? -2. And then what's 0 minus 5? -5. Now all we have to do is multiply all that together, and that number will be our y-intercept. So 3 times -2, that's -6. -6 times -5 is +30. So if you guys notice, I'm not going to label the y-axis, because after the y-intercept, we really won't know any other exact y values, and we don't really care. So I'm just going to put a mark way up here and say that's where y is 30, but I'm not going to mark anything else. Okay, once you have all of that, guys, those are the only exact points that make it onto this graph. Everything else is going to be a sketch. To get the rest of the graph, we need to know the end behavior. Which end of the graph is up? Which end of the graph is down? Are they both up? Are they both down? We need all that information. And to get that information, we need the degree of this polynomial, whether it's even or odd, and we need to know the sign of the leading coefficient. Well, guys, unfortunately, when it's given to you in factored form, you don't see that leading term that tells you what the degree is and what the leading coefficient was. So what you're going to need to do to get the degree and the leading coefficient, I want you to multiply all of your fronts together. So watch this. If we actually multiplied this out, we eventually would have to do, there's a positive 1 in front. You'd have to do positive 1 times x times x times x. Does anybody know what that is? What's 1 times x times x times x? It's 1x to the third. So guys, I promise you, if this was in multiplied out form, it would lead with a 1x to the third. So what degree is this polynomial going to be if it leads with a 1x to the third? It's degree 3, beautiful, which is odd. We know, according to yesterday's notes, that an odd degree polynomial's graph, the end behavior has to be what? Different or the same? Different. One end of the graph has to be up and one end of the graph has to be down on an odd degree graph. But which end is up and which end is down depends on that leading coefficient. So guys, who's the leading coefficient to that term right there? A positive 1. So when it was an odd degree polynomial and the leading coefficient was positive, do you remember which end of the graph had to be up? The right or the left? Anybody remember? Positive leading coefficient has to be up on the right, the positive side of the graph. So guys, we now know it's up on the right, it's down on the left. So what I do is I put a little mark. To the right of your last x-intercept, the graph has to end up. To the left of your last x-intercept, the graph has to end down. Okay. Now we're going to let the graph fill itself in. And I want you guys to notice something. When you got your x-intercepts, none of them repeated. They were only an x-intercept one time. None of these have a high multiplicity. None of them are repeating like x equals negative 3, x equals negative 3. Every time it only exists one time, it's a crossover. You just cross over the x-axis at that x-intercept. All right, so guys, here we go. Let the graph fill itself in. I know it has to end down, right? So let's have the graph down here. It's got to be down there to the left of the last x-intercept. Now let your graph head towards that first x-intercept. It's going to get there, and it's going to cross over. It's an x-intercept, right? It's going to cross over the x-axis. Now, I don't have another x-intercept until all the way over there. So this graph is just going to keep climbing and head towards that point. Now, for all I know, it turns here because I know it has to turn somewhere because it has to head towards the next x-intercept. So it's got to turn and come back down. It probably doesn't turn at the y-intercept. It might go up a little bit higher and then turn. But guys, this is just a sketch. It doesn't really matter. So I know after I go through the y-intercept, I'm going to have to turn and come back towards the next x-intercept. Okay. When I get to the next x-intercept, my graph has to cross over. It's an x-intercept. So cross over. And now my graph is going to go down, 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 and down. But guys, eventually, what's your graph going to have to do? Because there's another x-intercept. Eventually, somewhere, your graph has to turn and start coming back up. It's got it. You have another x-intercept. So the deal is, I don't care. Maybe I go all the way down here and turn. Maybe somebody else went to there and turned. It doesn't matter. That's the sketch. Our peaks and our valleys probably aren't going to be the same height or same, drop down. That doesn't matter. You just got to make sure that you go through this x-intercept, cross over, and then somewhere you guys got to turn and come back up. And now we're going to head towards the next x-intercept. And then that's an x-intercept, so we cross over. Now you see how you have no more x-intercepts to head toward. So this graph is going to stay up now. And that's exactly where it should end. And the graph should fill itself in. All right? So again, somebody else who did this graph, if I can get another color, guys, maybe your graph looked like this. Okay, maybe it looked like that. It's fine. It's the exact same graph. As long as your graph is down here to the left of this x-intercept, as long as your graph is up here in between these x-intercepts, as long as your graph is down here between these x-intercepts, and as long as your graph is up here to the right of this one, all of our graphs are correct, okay? So that's the sketch part. The peaks, the hills, the valleys, they may not be the same height. But guys, the big takeaway from this graph, all we really want to know is that if you were to plug any of these x values into that function, it's going to make a negative y value come out. If you plug any of these x values into that function, it makes a positive y value come out. If you plug any of these x values into that function, they make a negative y value come out. And if you plug any of these x values into that function, they make a positive y value come out. That's all we really care about. What x values make a positive y come out, and what x values make a negative y come out. I don't actually care what y value is actually on this graph. I just know that they're negative here, and that's all we take away from the sketch, okay? So I know it probably feels a little weird, but once you have your x-intercepts and your y-intercept and all of that end behavior figured out, the graph should fill itself in. All right, let's try it again. All right, let's come to example 2. Got to give this a chance to kind of feel a little bit normal. Why is that highlighted? No, wait. Oh, there it is. Okay, here we go. All right, so now we're going to graph this one. So let's set it equal to 0 and solve. We got to get those x-intercepts. Luckily for us, like I said, all of them are in factored form today, so we don't have to worry about factoring. All we got to do is set our factors equal to 0 and solve. So if I set this factor equal to 0, I would literally get x equals 0. If I set this factor equal to 0, I would get x equals 2. If I set this factor equal to 0, I would get x equals negative 6. And if I set that one equal, I would get x equals 5. And notice, none of them repeated. So all of them have that multiplicity of 1. All right, guys, let's plot them. But like I said, I think it's easier if you kind of space them out. Give yourself some room because the graph can get a little tight to make your turns. All right, we got one at 0. We got one at 2. We got one at negative 6. And we got one at 5. Those are the only spots where your graph should touch the x-axis. It cannot cross over unless you have a dot. All right, now we want that y-intercept. The y-intercept is just when x is 0. So we got to plug 0 in to find it. So let's do f of 0. So guys, if I plug 0 in, that's going to be 0 right there times 0 minus 2, negative 2. 0 plus 6, 6. 0 minus 5, negative 5. But guys, at the end of the day, the minute you put a 0 there, what's 0 times all those numbers? It's 0. So whenever you have an x-intercept that is 0, it automatically makes the y-intercept 0 as well, because you can only cross the y-axis one time. All right, so we got that. Now I got to figure out my end behavior. What's this graph doing? Where is it up? Where is it down? What's happening? So in order to do that, you need the degree, even or odd, and you need the sign of the leading coefficient. But like I said, this being in factored form, we don't see that leading term. So in order to get that leading term, I need you to multiply all the fronts together. So that's a 1x times an x times an x times an x. So guys, what's an x times x? X squared times an x is x to the third times an x is a 1x to the fourth. If this polynomial was multiplied out, it would lead with a 1x to the fourth. All right, so guys, what degree is it if it leads with a 1x to the fourth? It is degree 4, which means it's even. And what do we know about the end behavior of an even degree graph? They have to be the same. Either both ends are up or both ends are down. Always on an even graph. All right, well, the leading coefficient. The leading coefficient is assumed to be 1. So guys, if you have a positive leading coefficient on an even degree graph, are both ends up or are both ends down? Both up. Those are the rules that we wrote down yesterday. Think about your parabola. If that leading a value is positive, the parabola went up. All right, so guys, to the left of your last x-intercept, your graph has to end up. So give yourself a mark. You got to end up to the left of the last x-intercept. Now, go to the right of your last x-intercept, and your graph also has to end up. All right, now, all of these x-intercepts did not repeat, so they are straight cross over the x-axis x-intercepts. All right, here we go. So I always do left to right. You can do it wherever you want. I'm going to start where I know my graph has to end, and I'm going to head towards that first x-intercept. I'm going to get there, and I'm going to cross over, right? Oh, I didn't plot the y-intercept. Oh, I did, it's 0. Okay, so guys, you have to get from here to that x-intercept next. So obviously this graph, it's going to go down. How low does it go down? I don't really care. I just know that eventually, what do I have to do? I have to turn at some point and start heading towards the next x-intercept. So like I said, maybe I go lower than you. Maybe you go lower than me. It don't matter. We're all down here. So let's start turning. Let's head towards the next x-intercept. I get there, I cross over. All right, my graph is going to go up. But guys, I have another x-intercept. So what's it going to eventually have to do at some point? It's going to have to turn. So go as high as you want, but then you got to start turning. And then you got to head towards the next x-intercept. Cross over. All right, I can go down, 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 but what's your graph eventually going to do to go to that next x-intercept? It's got to turn. Again, maybe you go lower before you turn. That's fine. It doesn't matter. But we got to turn somewhere, and we got to start coming back up. I have no more x-intercepts to head towards, so my graph should end up where I said it should. And there's the graph of your degree 4 polynomial function. And again, somebody else's graph might have lower or even maybe a little bit higher. Maybe it's higher, maybe it's lower. It doesn't matter. The important part is when we plug these x values in, the graph is up here. When we plug these x values in, all of our graphs are down here. When we plug these x values in, all of our graphs are up there in a positive y value. And then all of these x values are down here. They make a negative y value come out. And then all of these x values make the graph go up there with a positive y value. That's all that matters. How do you guys feel? Does it feel weird? Does it feel okay? We all right? Yes, at home, thumbs up? All right, let's keep going. Let's do it again. Again, the more practice you get, the better and easier these feel. All right, here we go. Let's set it equal to 0, and let's get our x-intercepts. So guys, you have to set negative x equal to 0. You just divide that negative 1 away, and you still get x equals 0. So you're still getting x equals 0 from that one. All right? Set this one equal to 0, I get 4. Set that one equal to 0, I get negative 2. And if you look at them, none of them repeated. None of them have a multiplicity, right? So let's plot them. I got 0, 4, and negative 2. Okay? Now let's get that y-intercept. It's the only other official point that you put on the graph. All right, in the y-intercept, x has to be 0, so we have to find f of 0, which is going to be a negative sign, then a 0, then 0 minus 4 is negative 4, 0 plus 2 is 2. But guys, the minute you put 0 in here, you multiply all this together. What does it multiply to? 0. Every time the x-intercept is 0, you're going to have a y-intercept of 0. All right, good. All right, now we need our degree, and we need the sign of the leading coefficient, okay? So to get your degree, because this is in factored form, you got to multiply all your fronts. So that's a negative x times an x times an x. A negative x times an x is a negative x squared, times another x is a negative x to the third. So guys, if this polynomial was multiplied out, it would definitely lead with a negative x to the third, which means it's degree what? 3, which is odd. Yes, go ahead. You could, but you have to be careful. If they, like, let's say this one was x equals negative 2, and there was another x equals negative 2, then technically that would be a degree 4, but you only have 3 dots because this one repeated. So when they start to repeat, and they're not repeating today, that's probably tomorrow, you could mess yourself up by counting dots and missing the ones that repeated. So I always multiply the fronts out because you're going to need your leading coefficient anyway. All right, but yeah, if you think about it, you could technically as long as you count the repeats more than once. All right, good call. All right, so it's degree 3, which is odd. Guys, what does the end behavior of an odd degree graph have to be? It's got to be different. So one end is up and one end is down. But which end is up and which end is down depends on that leading coefficient sign. So who's the leading coefficient in this problem? -1. So guys, if your leading coefficient is negative, now is it up on the right and down on the left? Or is it up on the left, the negative side of the graph, and down on the right? This is what it's doing. If you have a negative coefficient, then you should be up to the left, the negative side, and down to the right. So to the left, I'm going to write that. Up, left, down, right. So to the left of your last x-intercept, you need your graph to end up. And then to the right of your last x-intercept, you need the graph to end down. So give yourself those little targets to hit. And then the graph should fill itself in. And remember, none of these x-intercepts repeated. They don't have a multiplicity. So that means they are just straight crossover x-intercepts. All right, so I start left. I'm going to start up here. I'm going to head towards my first x-intercept. All right? The next point I need to hit is right there. So guys, eventually my graph has to turn and come back up. So come back up. And again, maybe you went lower than me. Doesn't matter. We're going to get there. We're going to cross over. Then my graph is going to go up. And it's going to go up and up and up. And then what's it going to have to do eventually to get to the next x-intercept? It's got to turn somewhere. So I got to start making it turn. And then it's going to cross over. And then once it crosses, guys, I don't have any more x-intercepts. My graph should end down. And there is the graph of this degree 3 polynomial function. And again, it's just a sketch, but everybody's graph should be up here for these x values. It should be down here for these x values. It should be up here for those x values, and then it should be down here for any of those x values to the right. And that's all we care about. All right, how do you guys feel? You guys okay? Yes? Everybody at home, are we all right? Yeah? Okay. Can we do one more? We got this. Come on. Here we go. Let's do one more. Let's set it equal to 0. And let's get our x-intercepts. Guys, if I set -2x equal to 0, you divide by -2. You're getting 0. It's x equals 0. All right, I set this equal to 0. I get 5. I set this equal to 0. I get 1. I set this equal to 0. I get -3. Let's put them on the graph. And notice, none of them repeated. They all have that multiplicity of 1. And again, try to space it out if you can, because otherwise it can be a little tight to make your turns. All right, we got 0. We got 5. We got 1. See, that's going to be a little bit of a tight turn in there. And we got -3. All right, the y-intercept. Guys, if you have an x-intercept at 0, what is your y-intercept automatically going to be? 0, because you're going to plug a 0 in there. -2 times 0 is 0. 0 times any of that is going to be 0. So I'm not even going to show it because you should already know that's something you could kind of skip. You know the y-intercept is going to be 0. All right, let's do it. We need the degree, and we need the leading coefficient to fill in that end behavior. So let's multiply our fronts. -2x times x is -2x squared. Times another x is -2x to the third. Times another x is -2x to the fourth. So that makes this a degree 4, which is even. And what does the end behavior of an even degree graph have to be? Both up, both down. It's got to be the same. Which one is it depends on that leading coefficient. Guys, the leading coefficient is -2. If the leading coefficient is negative, that means both ends have to be down in the negative direction. All right, so the left of your last x-intercept, we got to be down. to the right of my last x-intercept, I gotta be down. And then it should fill itself in. All right, so I'm gonna go towards that first x-intercept and cross. Eventually I gotta turn. So start turning and cross. I'm gonna go down. This is the tight turn I'm talking about. So now we're gonna have to turn and then go back up. And again, maybe it goes lower, it don't matter. We're gonna cross, go up, but then turn, and then I gotta stay down. I'm out of x-intercepts. And you're done. How do we feel? Everybody okay? All right. So guys, for homework, I gave you guys 3 questions for homework. Let me show you. It's a Google slide. Everybody will just, okay. Just in case I can save any questions or confusion. Here's what your homework's gonna look like. You have 3 of these. I give you a polynomial function, you're gonna do it. I gave you dots. There's enough for your x-intercepts and your y-intercept. Guys, I recommend don't click on the dot until you see those 4 arrows. If you click on it, once you try to move it, you're gonna change the size of it. So click off of it and just hover over it. And as long as it's those arrows, it'll let you move it to where you want it without changing the size of the dot. Then, to fill your graph in, guys, you see this arrange word? Right under it, there's this line symbol. If you click on the line symbol and you scroll all the way down to scribble. Guys, the scribble lets you scribble and you can fill your graph in like that, okay? So you're gonna move your dots to your x-intercept and y-intercept, and then you're gonna use under the word arrange, there's this line feature, go all the way down to scribble, and then you can scribble your graph in. Does that make sense? Is everybody okay? All right, and there's just 3 of them. I asked you to do 3 graphs. I gave you enough for your x-intercepts and your y-intercept, and then you just use that scribble feature to fill the graph in, okay? At home, are we okay with that? You gotta do 3 on the Google Slides, all right? All right, let me double check the attendance. I didn't get to the last example, but that's all right. All right, let me double check the attendance, and then obviously if you have any questions, you can reach out to me.